Hi, hello everyone. So this is the second video dealing with section one, linear and absolute value equations. And in this second part, we're going to focus on absolute value equations. So the same techniques that we've used for solving linear equations, we're going to use for absolute value equations. Okay? We're going to balance the equation the exact same way. We're going to solve for one variable. We're going to leave that variable isolated in one side and the number on the other. But in addition to that, we have to cover what is an absolute value. Okay? So an absolute value equation is an equation where the variable that we're trying to solve exists or appears inside an absolute value function. So an absolute value function is this thing with the two bars around either a number or a variable. Okay, so I have two examples here. The absolute value function is very, very easy. It's just uh, whatever number you put inside of these two bars, the absolute value, the answer comes out positive. So the absolute value of 5 is 5. The absolute value of -5 is also 5. The absolute value, right? So without regard to sign. Now, if we have a variable, now we don't know if this variable is positive or negative. So there is going to be two answers. The answer may be x if x is greater than 0. But the answer is going to be negative x if x is less than 0. Now, obviously, if x is 0, the answer is 0. But so this is important for you to understand, right? If this value here is negative, like -3, then the answer is -3, which is +3. Okay, so this is the definition of the absolute value function. We don't really need it. I just gave it to you right now because I want you to understand what it is. Okay, what's important for you to understand is here. Whatever number you put inside of the absolute value, it comes out positive. So here's some examples for you to see. Absolute value 8, absolute value -7, absolute value -5.309, just a positive. Absolute value 0, 0. Absolute value -123, positive 123. So everything comes out positive. Okay. Now, when we solve, because of the issue with the definition I gave you a couple minutes ago, when we solve absolute value equations, right? Because of that issue with what if it's a variable? Then we don't know. There may be two answers, x or -x, depending if this is positive or negative. Now, because of this, we are going to have to solve two linear equations. Okay, one that assumes the value is positive and the other assumes it's negative. So this has to be done every single time. So we're going to do the exact same thing. Always we begin with the following steps. Isolate the absolute value in one side, and then we're going to create two linear equations, and then we're going to solve them separately. Now, because we don't know what is the case with the variable, we have to check the solution at the end. Okay, so steps 1 through 4 need to be done for absolute value equation. So isolate the absolute value. All right. Create the two linear equations, step 2. Solve each equation separately, step 3, and then you check. You have to check. Even if the question doesn't ask you to check, you must check to see if it's correct. All right, so let's see how this is done. I have 3 examples, 2 are right here. And again, there are more examples in the workbook. So let's see this example. In this case, the absolute value is already isolated in one side, so we can begin. So we go into step 2, which is splitting this equation into 2. So here are the 2 equations, and this is how you're going to do it. Okay. The first equation, so it's going to be the positive one. All you have to do is remove the absolute value sign, and you're going to solve it. This becomes a linear equation, right? So we already know how to solve -4 on both sides, 28, and then divide everything by 7. So this is one answer, right? The 7's cancel, 28 divided by 7, 4. The second equation is going to be the negative one. So you're going to remove the absolute value from the left side, and you're going to add or introduce a minus in front of whatever is on the right side. Okay, this is very important. You have to solve two equations. And then you're going to solve this the normal way. So again, -4 on both sides. And then we divide everything by 7. Okay. In this case, we cannot divide. We also cannot simplify the fraction. So this is the final answer. Now, we're not done yet. We have to check to see if these solutions work. Maybe this one works, the one on the left. Maybe this one works. Maybe both work. Maybe both do not work. We have to check. All right. So to check, I am going to replace them in the original equation. Okay. And see if we have an equality. So let's see. So let's do number 4, x equals 4 first. So 7 times 4 plus 4, 32. Now this is 28 plus 4, 32. So this is what we have. Is the absolute value 32 equal 32? Yes, it is. So that checks. So this is good. Now let's do the 36. I'm sorry, the negative 36 over 7. So this one worked. So let's do the second one. So replace the x, negative 36 over 7 for x inside of the radical. So 7, negative 36 over 7 plus 4 equals 32. And we have to check to see if it's correct. So the two sevens cancel. I get negative 36 plus 4 equals 32. What is negative 36 plus 4? That's negative 32. Is the absolute value of negative 32 equals 32? Yes, it is, right? Because the absolute value cancels the minus. So this is okay, which means that this is also okay. So both of these solutions are correct. So they have to be checked. We don't necessarily know if both answers will be correct. We have to check. Okay. All right. Let's do the next problem. I'm going to erase this a little bit here. Now, in this case, problem 114, the absolute value is not isolated. So I cannot begin with this -5 here. So I have to remove it from here, and I do that by adding 5 to the left side of the equation. And if you do that, you do the same thing on the right side. So they cancel now, and I'm left with 9 plus 5. And now at this point, it kind of becomes similar to my 1.12 problem. And we go about the exact same way. We create at this point two equations, the positive one and the negative. The positive one, I just remove the absolute value sign and solve it, right? Isolate the variable, divide by 3, We get an answer. The negative one, you remove the absolute value side and you multiply whatever it's on the right side by a minus. We solve it the same way we did before. Get rid of the 4, right? Negative 4 on the left, negative 4 on the right. You cancel. This is negative 18. Divide both sides by 3. And we get negative 6. So we get two possible answers. They both have to be checked, okay? We cannot just go about because one may not work. And we check it in the original equation. So I'm going to do the negative 6 first because it's easy. So 3. So replace x with negative 6 plus 4. Forgot the minus 5 there. So let's just write that. Minus 5 equals 9. So we have to check to see if it's correct. So this is negative 18 plus 4, negative 14. Okay. Well, let's see. So absolute value of negative 14 is positive 14. Positive 14 minus 5 is 9. That checks. So this guy checks. Okay. Now let's check the other one. The 10 over 3. 10 over 3 plus 4 minus 5 equals 9. So the 3 cancel. I got 14 here. Equals 9. Well, so the absolute value of 14 is 14, minus 5 is 9, so that also checks. So in this case, again, both answers are correct, which is fine, but they still have to be checked. Now, we're going to see another example where this is not going to be the case, and that's why we have to check. Let's see our last example, which is this one. Okay. And let's see how to do this problem. Now, in this case, I have two pieces with an absolute value sign. And in this case, since they're both already isolated on their respective sides, we're ready to begin or go to step 2, which is split them. The positive equation. Now, notice, you might be thinking, well, Professor, but what if there's a number here or something else there? Yes, so that would make it a little bit harder, but we're not going to give you anything other than the examples that you saw in this video or in the workbook. Okay, so these are the only ones that you're responsible for solving. Okay, either the two cases we demonstrated before or this one right here. So in this case, they are both already isolated. So the positive equation is just the equation without the absolute value sign. And we solved that. And as you can see, it looks like a regular linear equation, which it is. Okay. So I am going to subtract 10x from both sides. And here they will cancel. I have negative 3x minus 14 equals 1. And then as you can see, you cannot have the number on this side. So I'm going to add 14 to both sides. Negative 3x, 15. And then obviously we divide everything by negative 3. The negative and the negative become a positive. The 3 and 3 cancel each other. I have x, and obviously the minus is going to go up. So negative 15 divided by 3, negative 5. So this is one solution. Now, notice the negative equation is going to be remove the absolute value sign of the left, remove the absolute value sign of the right, but there's going to be a minus that is going to multiply the whole thing. Now, do not do this. This would be incorrect, okay? If you just put a minus here, that is wrong because the minus has to be upon everything or acting on everything. So if you have multiple terms on the right, you put parentheses first, okay? Now this is the correct way to do it. Now you have like a -1 multiplying this and that. So we take care of the parentheses first. So that will be -10x minus 1. And now you have a basic linear equation. So we go about doing the exact same thing we did before. So remove the variable from the right side by adding is inverse identity. They cancel here. I get 17x minus 14 minus 1. Take care of the number here. So plus 14 plus 14 on both sides. They cancel. I have 17x equals 14 minus 1, 13. Always make sure that you have not done a mistake, made a mistake somewhere, right? Especially if these numbers are like weird, like they are right now. So we can check our work. Let's check our work right now. So let -10x minus 1, that looks okay. Add 10x both sides. I got 17 minus 14. This is -1. Add 14 to both sides. Okay, that cancels. 17x, 13. Divide everything by 17. And that looks good. So they're both good, but they have to be checked. Okay, we cannot just go ahead without checking. So the check is on the original equation as it is. Okay, so I'm going to check the -5 first because it's easier. So -5. So 7, -5 minus 14 equals 10, -5 plus 1. So let's see. The 7 times -5 is -35 minus 14. This is -50 plus 1. So this is -49. And this is -49. So that checks. That is okay. Okay. Now let's see the 13, 17. So 7. This is going to be a very mean number. 13, 17 minus 14 equals 10. 13, 17 plus 1. All right, so you might need a calculator for that. So I can take a look at the right side, seems easier. So this is going to be 130 over 17 plus 1. And who knows what that is? I need a calculator for that. So here's my calculator. So 7 times 13, 91 over 17. This is 91 over 17 minus 14. So we have to check to see if these are the same thing. Okay. Maybe you can see if they are or if they are not immediately. Okay. So there's different ways you can do this. You can do it using fractions. I'm going to have to erase this part. Didn't want to do that, but let's erase this part because I'm going to need the space for this. Okay. So how do we do this? Now we can find a common denominator or we can, find a decimal, right? So maybe with the decimal is enough. Now, normally, if this is a problem on your exam and you need to show work, you would need it to leave it as a fraction. But I think for the purposes of just checking, we don't need it. So let's do 91 divide by 17. I think the answer is obvious. You don't even need to do that, but I'm going to show you anyway. Um, so I think I divided 91 by 17. And we got this 5.35. Now, minus 14. So this is negative 86470. So this is approximately negative 8.6470. So let's see if that's the same as that. 130 divided by 17 plus 1. Here is, now remember, this is an absolute value. And here's my 86470. 8.6470. Now, is the absolute value of negative 86470 equal? Yes, it is. So in this case also, both the equations came out, both solutions came out correct. So they are correct. Now, in the event one of them did not work, so this usually happens when you have a quadratic equation inside of an absolute value, which I don't think you're going to get, that needs to be verified. Okay. But in these cases, as you saw, they came out okay. Now, is it always the case that this is going to work? No, it is not always the case. Okay. I'm going to give you a simple example here very quickly. I didn't put it here because I don't think it's important. You may have one in your um, workbook. So let's say I have this equation right here. Call it, the next problem. Okay, so absolute value 2x plus 3 plus 2 equals 0. So the very first thing that we do is subtract 2 on both sides, right? Because we have to isolate the radical. And then we divide the equation into 2. So 2x plus 3 equals negative 2. This is the positive one. And 2x plus 3 equals minus a negative 2. So we go about solving them. So minus 3 here, minus 3 there. We got 2x negative 5. Divide everything by 2, we get this. This is 1. The second one is we first multiply that. Minus 3 on both sides again. And we divide by 2, we got 1/2. So we got two answers. Okay? We have to check them. We check them against the original. Okay? So I am going to do the 1/2 first in here. So 2 1/2 plus 3 plus 2 is a 0. So obviously these two cancel. I have 1 plus 3 is 4. Plus 2, is that going to be 0? No, right? Because absolute value 4 is 4 plus 2 is 6, not 0. So that one is out. Let's check the second one. Replace x with the number. So again, the 2's here cancel, and I have negative 5 plus 3, negative 2. Is absolute value negative 2 plus 2 0? Well, the answer is also no, because the absolute value of negative 2 is 2. Plus 2 would be 4. So in this case, both answers did not work. So if that happens, you would have to write on the problem, no solution. Okay? None of them work. So if you stopped at this point with the two answers without checking them, this would only be partially correct because as you can see, neither solution worked. So if that's the case, you write no solution on the problem. Okay, so this is how you write and solve absolute value equations. And in these cases where you saw solutions worked, they have to be checked. Or in this last case where the solution did not work and you wrote no solution.